In this video, I am doing problem number 9 from homework 2.5 part B. The zoo is building a new polar bear exhibit and wants to put a semicircular window in the concrete wall of the swimming tank. If the semicircle has a diameter of 120 centimeters and the bottom of the window is at a depth of 2.5 meters, find the hydrostatic force on the window. So the first thing we need to do is draw ourselves a picture, which I've already done here. And so the big rectangle is the tank, and we have the semicircular window. And it's going to be helpful to think of centering the semicircle at the origin of the XY axis. That's going to help us with the equation for finding the width. So the acceleration due to gravity we know is 9.8. Density of water is 1,000. And I also situated this so that y equals 0 will be at the bottom of the window. And so the top of the tank is going to be 2.75 because the bottom of the window is 2.75 meters down. So that means for any given value of x here, that the depth of this value of x is going to be 2.75 minus y, because y is being measured from 0 up from the bottom. So that means it's going to be 2.75 minus y down from the top, which would be the depth. All right, so let's get started. The first thing that we need to find is the width function. The width function at depth y. So if you look on here, I've drawn this green line to a point on the semicircular window, xy. And so we're going to let 2x is going to be the entire width across here. But just to find this value of x, this point xy, we can use the equation of the circle, which I've done down here. X squared plus y squared is equal to the radius squared, and the radius is 0.6. So x squared plus y squared is equal to 0.36. Let's solve that for x, which is this distance right here. And that will be the square root of 0.36 minus y squared. And of course, the width of the window at any given depth y is going to be 2x. So the width is going to be 2x, which is 2 times the square root of 0.36 minus y squared. So there's our width function. The other thing we need to do is then find the depth function, which I've already said is going to be 2.75 minus y. So that's the depth function. Then all we have to do is set up our integral. So the integral is going to be the density times acceleration due to gravity, 9.8 times 1,000 or 9,800. And the integral, the bounds are going to be from 0 to 0.6. Because remember, 0.6 is the radius of the circle. So we're going from 0 to 0.6, which would be right up here. And so then we multiply the width function times the depth function, dy. I didn't actually go through and do the integrating. This is a problem that you're going to want to set up in Desmos. Once you get to this point, set this up in Desmos, and Desmos should give you the answer 13,828.67 rounded to 2 decimal places. All right, hopefully this helped.